Welcome to clickmyproject.com. Now let me discuss about bind progressive quantization for compressive sensing. Here we propose a method in the compression of images. In pre-processing, we remove the noise from the images. After removing the noise, the image will be quantized by the discrete wavelet transform, which is used to decompose the images. It converts the image from spatial domain to frequency domain. The CS encoder is made signal independent and computationally inexpensive by shifting the bulk of system complexity to the decoder. While these properties of the CS allow signal acquisition and communication in some severely resource conditions that render conventional sampling and coding impossible, they are accompanied by rather disappointing rate distortion. Performance. After quantization, we encode the image by the use of split algorithm. This will generate the coded value for an image. After that code will be given to the dequantization for reconstruct the images. After that, inverse wavelet transform will be applied. Finally, it reconstructs the original image. This is the flow of our project. Here we have to provide an input image. The input image is passed to the pre-processing stage. In pre-processing, we remove the Gaussian noise by applying the Gaussian filter. So after that, here we are having the noise-free image. The noise-free image is passed to the quantization. In quantization, here we are applying the wavelet transform. It performed first, followed by the predictive coding technique on the transformed image. And all these methods use Haar filter in the lifting scheme, and the filter coefficient will be identified. The simplest lifting scheme is the lazy wavelet transform, where the input signal is first split into even and odd indexed samples. After quantization, it will be encoded. In encoding, here we are using the split algorithm. Partial ordering of the transformed image elements by magnitude with transmission of order by a subset partitioning algorithm that is duplicated at the decoder. After encoding, here we are having the bit stream. The bit stream will pass to the decoding. The encoder and decoder have same sorting algorithm. Then the decoder can duplicate the encoder execution path if it has received the result of magnitude comparison, and the ordering information can be received from the execution path. After decoding, it will pass to the dequantization. In dequantization, the inverse wavelet transform uses predict and update operation of orders 1. Using different predict and update operation of higher order, many other wavelet transforms can be split using the lifting scheme. Finally, we get the reconstructed image. Now let's see the execution part. Here I am having cs.main file. It is the main file. Select this file, right click, run the file. The guide window will be open. This is our guide design. Here I have to provide an input image. In dataset, totally I am having 6 images. Now I am providing one image as input. The provided image is displayed in the first axis. In pre-processing, here we are removing the Gaussian noise. For removing the noise, here we are using the Gaussian filter, and finally we get the noise-free image. Now let's see the result. This is the noise-free image that is displayed in the second axis. This noise-free image will pass to the further process. In quantization, the noise-free image will be quantized by the use of discrete wavelet transform. A discrete wavelet transform, it will decompose the images, and it will convert the image from spatial domain to frequency domain. Now let's see the result. This is the quantized image of original image. In encoding, here we are using the split algorithm. Split stands for set partitioning hierarchical tree. It will encode the image as a bit stream. The bit value of images will be output. These are the bit stream of our input image. This bit stream will be reconstructed here. In decoding, the bit stream will be passed here, and it will provide the quantized image. This is the quantized image. This quantized image will pass to the reconstruction. In reconstruction, inverse wavelet transform will be applied, and finally we get the original image. This is the original image. Now we are providing the bind progressive quantization method that will provide the better result, and it is also provide the lossless compression of image. Thank you.